All right, welcome ladies and gentlemen. This is Ready Lesson 2, Find the Area of Triangles and Other Polygons. So let's go ahead and go to page 22. Here's page 22, problem 2. It says, look ahead. As in a parallelogram, the base and the height of a triangle are perpendicular. Any side of a triangle can be called the base. The corresponding height is drawn from the vertex that is opposite the base. So keep this in mind. It says use a solid line for the base and a dotted line for the height. The base and the height will always meet at a 90-degree right angle, the perfect square corner. So let's go ahead and take a look at these two examples here. So for the first one, let's go ahead and use a solid line for the base. Go ahead and trace. And for the height, we're going to start at the top of this triangle and drop straight down like you're dropping a rock. And remember that the base and the height will always meet at a perfect square corner. They're perpendicular to each other. So go ahead and draw that perfect square corner right over here. Now for the next example, notice that it feels like the triangle has been rotated. So this is the base right here, and then this is the height. And even though it's rotated, it's still going to meet at that perfect square corner. So go ahead and trace the base with a solid line. Use a dotted line for the height. And again, the base and the height will always meet at that perfect square corner. Go ahead and trace it. And you can see that the base and the height are perpendicular to each other. They meet at that perfect square corner. Here's letter A. Use the triangle at the right. Draw the height that corresponds to the side labeled as the base. Then write the lengths of the base and the height. So let's go ahead and use a solid line for the base. Go ahead and trace. And let's measure. We have 1 unit, 2, 3, 4, 5, 6, 7, 8. The base is 8 units long. Now for the height, start at the very top of the triangle. Pretend you're dropping a rock straight down. And it will meet at a perfect square corner with the base. The base and the height are perpendicular to each other. And the height measures 1, 2, 3 units. Write down that the height is 3 units. So the base is 8 units, and the height is 3 units. Let me clean that up a bit. Letter B. Use a triangle at the right. Draw the height that corresponds to the side labeled as the base. So here we have the base. And to make this easier, let's go ahead and extend the base with a dotted line. So from here, I'll draw a dotted line. And then when we drop the height from the top of the triangle, you can see that it will still meet at a perfect square corner with the base. So this is the base right here. Oops, let me switch that to a solid line. And here is the height. Next is page 23, number 2. Number 2 says, is this polygon a parallelogram? Explain. And yes, this is a parallelogram, so write that down. Yes, this is a parallelogram. But why? What makes this a parallelogram? So the first reason is that the left and right are parallel to each other. They're going in the same direction. So we're going to indicate that with a single arrowhead on the left and on the right. So draw a single arrowhead. And that shows that the left and the right are parallel. They're both going in the same direction. And not only that, the top and bottom are also going in the same direction. They're parallel. And we're going to indicate that with a double arrowhead. So let me draw a double arrowhead for the top and a double arrowhead for the bottom. So for number 1, let's write down that the left and right are parallel and the top and bottom are parallel. The left and right are parallel. And the top and bottom are parallel. Here's reason number 2. Also, the left and right are equal lengths, and the top and bottom are equal widths. So you'll notice that the left and right, they're the same length, and the top and bottom, they're the same width. So let's write down also, comma, the left and right are equal lengths, and the top and bottom are equal widths. And those are 2 ways that you can tell that yes, this is a parallelogram. Next up is page 28, number 8. It says, Elena claims that the expression 1/2 times 4 times 5 represents the area of the triangle in square inches. Explain why Elena is not correct. Then explain how to correct her error and find the area of the triangle. So let's take a look. We know that to find the area of a triangle, we need the base and the height. And the base and the height will always meet at that perfect square corner. So we'll call 4 inches the base, and we'll call 3 inches the height. So Elena says that 5 is either the base or the height of this triangle. And we know that's not correct because this length of 5 inches does not meet that perfect square corner right there. So Elena is wrong. Let's write it down underneath. Elena is wrong. Period. The 2 lengths that are perpendicular to each other to each other are, let's take a look, they are 3 inches and 4 inches, not 4 inches and 5 inches. So the 2 lengths that are perpendicular to each other are 3 inches and 4 inches. They meet at that perfect square corner. 3 inches and 4 inches, and not 4 inches and 5 inches like she was claiming. So it is not 4 inches and 5 inches. Elena is wrong. The 2 lengths that are perpendicular to each other are 3 inches and 4 inches, and not 4 inches and 5 inches. So let's go ahead and calculate the area of this triangle. I know that the formula is area equals 1/2 base times height. And once again, we'll go ahead and use 4 inches for the base and 3 inches for the height. They meet at that perfect square corner. That means that the base and height are perpendicular to each other. So we'll write down 1/2 times 4 inches times 3 inches. We'll simplify, divide by 2, divide by 2. That gives us 1 and 2. So we can see that our final answer is 6 inches squared, or 6 inches squared, if you were asked to spell it out. The third way to say that is 6 square inches. So the area is 6 square inches. Here is page 31. Develop, finding the area of a polygon. Here's the scenario. A costume designer is making a superhero costume for a movie. The costume will have a logo on the front. The designer draws a plan for the logo on 1-inch grid paper. What is the area of the logo in the drawing? And you can see that the logo on the front of the costume here is in the shape of a diamond. And it is represented here on this 1-inch grid paper. So let's go ahead and do a little bit of review first, because this is a complicated shape that we have never found the area of before. So let's look at some simpler shapes. Write this down. We have the area of a rectangle, the area of a parallelogram, the area of a triangle, and the area of a trapezoid. And these are all basic shapes that we've studied before. So let's come up with the formulas for each one. The area of a rectangle, that's pretty simple. It's just base times height. For a parallelogram, I know that I can turn it into a rectangle, so the area of a parallelogram is also base times height. Next, a triangle is half of a rectangle, so the area of a triangle is 1/2 base times height. And finally, the area of a trapezoid. A trapezoid has 2 bases, not just one. And it looks like a triangle with the top cut off. The top base and the bottom base need to be parallel to each other. So let's write down that the area equals 1/2. And it's not just one base, it's base 1 and base 2. And then all of that times the height. So these are some basic shapes that we know the formula for area. We have not studied the area of a diamond before, but the good thing is that we can decompose this into simpler shapes. So we're going to decompose. That just means to break it up into simpler shapes. So if we draw a line right through here, you'll notice that the top shape here, that now turns into a basic shape that we do know. So this is a trapezoid. I'll write down trapezoid up here. And draw an arrow pointing to that portion of the logo. And now look at the bottom portion of the logo. This part here in green, we have just created a simpler shape, and that is a triangle. So write down triangle and draw an arrow pointing to the green portion of the logo. So all we have to do to find the area of the logo or of the diamond is take the area of the trapezoid, add it with the area of the triangle, and then you have your total area for the entire diamond logo. So let's go ahead and write that down here. Don't write too big or you will run out of space for this problem. So we'll write down that the area of the diamond equals, switching to blue, the area of the trapezoid plus the area of the triangle. And I'm going to give myself a lot of space for this problem. So we'll work on the trapezoid first. We'll work on the area of the triangle. And when we add them together, we will have the area of the diamond. So area of trapezoid plus the area of the triangle, you will have the entire logo. So let's work on the area of the trapezoid first. I know that the formula is right here. 1/2 the quantity, base 1 plus base 2 times the height. So I need base 1 and base 2, and I also need the height. So looking at the trapezoid, we can call this one base, we'll call this one base 2, and we'll call this base 1. So we also need to make sure that they are parallel to each other. So just go ahead and draw a single arrowhead showing that they're parallel. So base 1, it is 1, 2, 3, 4, 5, 6 units long. So I'll write down that base 1 is 6 units. Base 2 is 1, 2, 3, 4 units long. We'll write it down. And now we just need a height. So a convenient place to measure the height is starting from here. Pretend you're dropping a rock, and it will always meet the base at a perfect square corner. It is perpendicular. And there's a perfect square corner right here, so it meets that base at a perfect square corner as well. So let's draw the base, actually the height. It meets at a perfect square corner here and here. And you can see that it measures 1, 2 units long. So now we have base 1, that's going to be 6. Base 2 is going to be 4. And the height is going to be 2. So let's write down the area of a trapezoid equals 1/2 the quantity, base 1 plus base 2 times the height. And I know that base 1 is going to be 6. Base 2 is going to be 4, and the height is 2. So let's write down 1/2 times the quantity 6 units plus 4 units, all of that times the height of 2 units. And in PEMDAS, we need to look at parentheses first. So inside the parentheses, I know that 6 units and 4 units, this is going to give me 10 units inside the parentheses. So on the next line, 1/2 times 10 units times 2 units. I'm going to wrap this up to make it easier to see. Times 2 units. Let's simplify. Looks like divide by 2 would be the easiest simplification. And here we can see that the area of the trapezoid is 10 units times units. There's 2 powers. Make sure you have both powers in your answer. So units times units equals units squared. And that is the area of the trapezoid, the blue portion of the logo. So this here is 10 units squared. Now let's take a look at the area of the triangle, the green portion right here. And we'll call this the base. I can see that that measures 6 units. And the height will start here. Looks like we're dropping an upside down rock. But notice that it meets the base at a perfect square corner. They're perpendicular to each other. So go ahead and draw the height. Meets at a perfect square corner. And it measures 1, 2, 3 units high. So my base is 6 units. My height is 3 units. Area of a triangle. is 1/2 base times height. The base is going to be 6 units. Height is 3 units. So on the next line, write down plus 1/2 times 6 units times 3 units. We can simplify the 2 and the 6. Divide by 2, divide by 2. That gives me 1 and 3. And I can see that my final answer is 9 units squared. And so far I have everything matching up, but I'm just missing one line right over here. So I'm just going to take this and bring it down, bring it straight down so that everything matches up line by line. So just go ahead and rewrite plus 9 units squared. Put the area of the trapezoid together with the area of the triangle, and you'll have the area of the diamond. So our final answer, 10 square units plus 9 square units gives us 19 square units. And one thing that I noticed here is that for the units, we're actually using inches. So let me go ahead and make one change to this. Since we're using inches as their units, we can also write down 19 inches squared, or 19 square inches. So using a complete sentence, what is the area of the logo in the drawing? The area is 19 square inches. Here is page 32. And on the previous page, we looked at how to find the area of this complex shape here, this diamond. And the way we broke it up is we drew a line right here and broke it up into a trapezoid and a triangle. On the next page, on page 32, we're going to look at 2 more ways that we could have decomposed that figure as well. So here in the first modelet section and in the second modelet section, let's look at 2 other ways that we could have decomposed that same logo. So here, this is another way we could have decomposed the diamond. Write it down. This is another way we could have decomposed the diamond. So here's that same diamond logo. And on the previous page, we drew a line right here to create a trapezoid, right here. But if you draw an extra line right here, notice that you have a triangle and a parallelogram. And then the bottom shape, that large triangle, is the same large triangle that we had previously. So let's go ahead and label each of those sections. In pink, right here, label that as a small triangle. Here in green, that is a parallelogram. And in this blue section right here, that's the same shape that we had on the previous page. This was a large triangle. Add them all together and you have your diamond logo. So we just take the area of the small triangle plus the area of the parallelogram plus the area of the large triangle and when you add all of that up together, you have the area of the diamond. And that is another way that we could have broken up this logo. And another way for breaking it up is to decompose. So that's another way to decompose that diamond, was by using a small triangle, a parallelogram, and a large triangle. Moving on to the second model it section, right over here. And here is yet another way that we could have decomposed. So write down yet another way. And for this one, we're going to use a subtractive approach. So we'll start with this huge rectangle here. And then now instead of putting things together, we're going to start taking things away. So if you start with this rectangle, take away this pink portion here and on the right side as well. So if you take away pink and then you take away these two green sections, we take that away. What do you notice is left on the inside? There's that diamond right here. So here's the exact same diamond shape. And again, instead of adding things together, we subtracted things. So we started with a shape that was too big. Take away the area of the pink. Take away the area of the green. And what's left is that shape that you wanted. So to figure that out, we'll write it down here. The area of the diamond equals, we started with the area of the rectangle, which was too big, minus the area of pink, and then minus the area of green. So let's just double check that. To get the area of the diamond, start off with the area of the rectangle. There it is. Take away the area of pink. Take away the area of green. And yes, indeed, you do end up with the area of the diamond. So this uses subtraction to figure out the area of that shape. Here's page 34, number 8. The polygon represents the top of a desk. What is the area of the top of the desk? Show your work. So we have this crazy shaped desk right here, and we are asked to find the area. And we haven't studied a shape this complex, but what we do know is that we can decompose to come up with easier shapes. So let's decompose this figure this way. We'll draw a vertical line here. And I end up with just a rectangle right here. And if I draw a line here, you'll notice that I end up with two more shapes. We have a triangle right here and another rectangle right here. So a key point of this problem is that we do have to stay organized, otherwise we're going to get lost. So right above number 8, I'm going to write down stay organized. And the way that we're going to stay organized is we're going to color code and we're going to give everything a name. So this section here, this is called section A in red. Then we have section B in blue. And finally, section C in green. And if we add up A plus B plus C, we will end up with the area of the entire figure. So let's go ahead and start attacking. In our workspace here, again, do not write too big or you will run out of space for this problem. Write down that the area of the desk, let me switch to red. The area of the desk equals the area, and I'm going to spell out the word area. The area of section A plus the area of section B plus the area of section C. So let's go take a look at each of these sections, one color at a time, one section at a time. We'll work on red first, the area of section A. So I know that this is just a rectangle, and to find the area, we can just do base times height or length times width if you choose. We'll go ahead and use base times height for this one. But we're going to have multiple bases and multiple heights for this problem. So instead of just calling it base and height, I'll call it base 1 and height 1. So right here, let's go ahead and write down that the area of section A equals base 1 times height 1, since we'll have many bases and many heights in this problem. Next, switching to blue. This is a triangle. So I know that the area of a triangle is 1/2 base times height. We'll use this as our base and this as our height. But it's different from this base and height, so we're going to call it base 2 and height 2. So in blue, let's write down plus 1/2 base 2 times height 2. And finally, green, this rectangle, again, base times height, but it's different from this base and height, and it's different from that base and height. So we'll call this base 3 and height 3. So the area of that rectangle is base 3 times height 3. So to simplify, the area of a rectangle is base times height. The area of a triangle is 1/2 base times height. And the area of that other rectangle is base times height. But I'm specifying which base and height we're using. This is base 1, height 1, base 2, height 2, base 3, height 3, so that we don't mix them up. So next up, let's work on section A, red. So base times height. This base is 120 centimeters, and the height is 50 centimeters. So let's write down 120 centimeters times 50 centimeters. 120 centimeters times 50 centimeters plus, now let's do the triangle. So I can see that the base here is 50 centimeters. It's the same as that one. The height is also 50 centimeters. It matches this here. So 50 centimeters for the base, 50 centimeters for the height. So we'll write down in blue 1/2 times 50 centimeters for the base times 50 centimeters for the height. Plus, now working on the green section right here, also base times height, base times height. So we have 50 meters for the, or 50 centimeters for the base, 80.5 centimeters for the height. So let's write down 50 centimeters in green times 80.5 centimeters for the height. Let's go ahead and simplify each section on the next line. So we'll simplify red, simplify blue, simplify green. So first up, we have 120 centimeters times 50 centimeters. I'll do my work up here in this workspace right over here. So 120 centimeters times 50 centimeters. I'm going to set up the multiplication like this. 120 centimeters times 50 centimeters. And I'm going to save my hanging zeros for later. So these two hanging zeros, just let them hang out all by themselves right there. So we have 5 times 2 equals 10. 5 times 1 is 5, plus 1 more is 6. And now we can bring down these two hanging zeros. 1, 2. So the answer that I have here is 6,000. So in red, we have 6,000 centimeters times centimeters equals centimeters squared. Next up, the triangle in blue. So let's simplify first. We'll simplify in purple. The 2 and the 50. Divide by 2, divide by 2. That gives me 1 and 25. So it looks like I need to do 25 times 50. I'll do it up here in blue. 25 times 50. And I'll write it like this with my hanging zeros. 25 times 50. Let that hanging zero hang out all by itself. I'll save it for the end. 5 times 5 is 25. 2 times 5 is 10, plus 2 more is 12. Now bring down that hanging zero. And I have 1,250. So in blue, write down plus 1,250 centimeters times centimeters, again, gives me centimeters squared, 2 powers. Next up, this rectangle in green, section C. Rectangle in green. So I'll write down plus. And we have 50 centimeters times 80.5 centimeters. I'll do my work up here in green. And I'll set up my multiplication with the hanging zeros as well. So 80.5 times 50, like this. And let that hanging zero hang out all by itself. We'll save it for the end. 5 times 5 is 25. 0 times 5 is 5, plus 2 more is 2. And 8 times 5 is 40. Now bring down this hanging zero. And we need to count all the decimal places after all the decimal points. So here's the decimal point. We have 1 scoop. Same thing in the answer, 1 scoop. And we have 4,025. So 4,025 centimeters times centimeters equals centimeters squared, 2 powers. And now let's just add them up. So in section A, this was 6,000 centimeters squared. Blue, draw an arrow, since it won't fit. 1,250 centimeters squared. And right here in green, draw my arrow that way. This is 4,025 centimeters squared. So let's go add everything up. I'll do it down here. 6,000 in red, 1,250 in blue, 4,025 in green, and our final answer looks like we have 11,275 centimeters squared. 11,275 centimeters squared. Box your answer. So the area of the desk is 11,275 square centimeters. Let's write our complete sentence. The area of the desk is 11,275 square centimeters. And we are done.